Hey everyone, we're in the last week really of content for this course. Week 12 does have some sort of optional content in it, but the main stuff is coming in this week. And we're going to kind of review a few topics that we've kind of been leaving up until now. Some of them are fun, some of them are just important. This first topic is exceptions. Now, if you take a look at the week 11 guide here, I mean, we've seen exceptions before. We know what they are. There's kind of a taxonomy of different kinds of errors that you can get when you write code. You can get the easiest ones to fix are the syntax errors. So these are the red underlines and so on in IntelliJ. The program won't even compile if there's a syntax error. Then there's a second type of error, which is where exceptions live, which is a runtime error. So this is a case where it's not a syntax error. The program will compile and it will run, but something that happens during runtime halts the execution of the program. The most classic way we've seen runtime errors is in this course is when the user types, you're using nextInt and the user types something that's not an integer, and it's going to exit then and throw an exception. So in Java, runtime errors are exceptions. And they're a little bit harder to debug than syntax errors. And then the hardest type of error, which is one that we know all about, are logic errors. So the program compiles, it runs to the end, but it just doesn't do what you expected. Those are the hardest ones. That's where you have to dig into your code and figure out where the logic is. So we kind of know how to deal with these kinds of errors, and I kept sort of putting off throughout the course, when are we going to learn how to deal gracefully with runtime errors? So that's what we're doing now. So a runtime error is most of them are exceptions, and it can be handled gracefully by the programmer. Basically, the code that triggers the runtime error will do an operation called throwing an exception. So an exception is an object. So the code that throws the exception will create an object, an exception object, by calling its constructor, and then we'll throw it, which is kind of like returning a value, but it's a different mechanism. So whatever code threw the exception will stop whatever it's doing at that moment as if it had returned a value, not execute any further code, and throw the exception. So that what we talk about is throwing the exception, and then if you want to handle it gracefully, you can catch it. You don't have to, though. You can, if your main method called some code that threw an exception, you can just choose to throw it again. So the exception gets thrown to you, you throw it on. You don't catch it, you throw it on. And if all the methods throw it, including the main method, if it continues the chain of throwing the exception, so it gets thrown from one method to another, to another, to another. If the main method throws it, that's when the program halts, and you get to see the stack trace, the big red block of code in the text. So let's take a look at some sample code here. This is this week's example code, the whole folder. You'll notice that we have the same problem that we had in a previous week, except one has an error in it, which is deliberate, which means that if you want to, the error comes from here. If you want to run other things, I'm going to show you this code, but if you want to run other things, you can comment out the offending line here, and then you'll be able to run anything you want, or you can remove except one. But we're going to look at it and see what it does. So this is a very simple little app. It's just meant to demonstrate catching and throwing exceptions. You might recognize this method. It exists in the animation template. I put a pause method in there. Well, no, this is a bit different actually from the animate one, but it's a similar idea. I put a pause method in there that calls thread.sleep. Now the reason why it's a little bit tricky is that now this one works a little differently too. Rather than saying I want to pause for 100 milliseconds, you say I want to pause using 30 frames per second. So then it divides 1,000 by 30 and figures out how long to pause, so that you would get 30 operations per second if it paused for that long. So the idea here is we're animating and we want to draw the screen over and over again. We tell the pause method how many times per second we want to do that drawing approximately, and it will give us an appropriate amount of pause time. Yeah. And then it pauses, and then this is just debugging, so we can see what's going on. Down in the main method, we have a scanner. We ask how many frames per second. The user enters an input using sc.nextInt, and then we call pause. Now there's all kinds of ways that exceptions can be thrown in this code, and we're going to look at all of them, and we're going to try and catch and fix all of them. So the first one, though, is what's causing the error. So if you hover over here, it says unhandled exception, java.lang.interrupted exception. So interrupted exception is the name of a class. It's a subclass of exception, which is a built-in class into the system. And here's the thing. Some exceptions are considered so important that you have to check them. So that means you have to basically specify what you're going to do with the exception. So most exceptions are not checked exceptions. So for example, we know that this line can throw an exception. I believe it's a number format exception. That could happen, but this is not a checked exception, so we don't have to specify what we're going to do with it. But this one we have to specify, the interrupted exception. So you can see up here, this method up here added some code to specify that it wants to throw the exception. If I take away that code, I get a syntax error here. So we're basically saying up here in the pause method, yeah, we know it's possible that the sleep method here could throw an exception. If that happens, so we're calling the sleep method, if it throws an exception back to us, we're going to throw it on to whoever called us. But that means that we've just put the responsibility of dealing with it to the main method. So we can fix it like this. This is the easiest way to fix it. It's not a graceful fix. Now, if thread.sleep did throw that exception, it would halt the program because we're throwing it from the main method here. So that's one way to deal with an exception that you have to check, a checked exception. This code will run now. So if I run the code, it will work just fine, assuming that I, as the user, behave myself and enter correct numbers. So if I say I want 5 frames per second, it will say that it paused for 200 milliseconds, and then it will exit. Now the thing about interrupted exception is this is judged by the designers of Java to be a very important exception. So what we're doing here is we're creating a blockage in this thread, and it is possible that some other process is going to come along and interrupt our thread, and that's when we would get the interrupted exception. We're never going to see an interrupted exception, and it's not very easy to cause one, so we can't really tell what would happen. We can't watch the exception get thrown or anything like that. But I can still show you the other way to handle it, and this is the way we'll be handling other exceptions that might be thrown by this code. What we do is we create a try-catch block, or try-catch statement. And it looks like this. Okay, so notice the error has gone away again. We're no longer saying we're going to throw it. Now we're saying we're going to catch it. What we do is we use the keyword try, and inside this block we can put any amount of code we want in here, but it should surround the code that might throw the exception that we're interested in catching. And then we can put one or more catch blocks after it, and these probably look like method declarations almost, like there's a parameter here. So basically, if the pause method throws the exception, if it throws an exception of any kind, we're going to come to the catch block and check to see if it matches the type that's here. If it does, then we will execute the code in the catch block. Okay, so that's another way to satisfy the requirement that we're dealing with the exception. So again, because interrupted exception is a special kind of exception that's checked, that we have to specify whether we're going to throw or catch it. So up here in the pause method, we specified we were going to throw it, which means it's going to come back here, and over here in the main method, we've decided to catch it. Okay, so those are the two basic ways of dealing with exceptions. Now, there's lots of other exceptions that this code can produce. And it's going to be very difficult for us to see this catch block running. So let's take a look at the other kinds of exceptions. You might want to think for a minute. Just look at both methods and think what other kinds of exceptions could this code throw. Okay, the most obvious one is it's asking the user to enter an integer, but I enter something that's not an integer, like this. And then I get this callback. So you can see what it's telling me is your code at this line, and if you click here, it'll take you to it in IntelliJ. This method that you called threw an exception, and you can see you called the nextInt method, which called another method called nextInt, which called another one called next, which called a special throw method for throwing exceptions. And the exception that it threw is this. Java.util is the package that it lives in, but the name of the object, the exception object that was thrown to us, was input mismatch exception. So it was like a return value. It threw that exception here, and since we didn't specify that we were going to catch it, the main method just automatically continued to throw it. We could add a throws input mismatch exception here, but we really don't have to do that because this is not that special kind of exception. We have to do it for interrupted exception because it's checked, but input mismatch exceptions are not checked, so we don't have to do it there. But what we can choose to do is we can choose to catch it. So let's try this. And you can see the name of the exception right here. So if there's any exception that you want to catch, you can do it like this. Input mismatch exception E. And what we can do here is we can say system out print line, that wasn't an integer. Like that. So now right now I can't run this code because I have an error. Cannot resolve symbol frames per second. So what's happened here? Here's frames per second. Notice it's grayed out here. I'm assigning to it and then I'm trying to use it down here. Take a minute to think about it. What's gone wrong here? So it's a variable scope error, right? So the rule, if you remember in Java, is that if you introduce a variable inside a block, it's only available within that block. So this frames per second variable is not available out here. So to fix that, what we want to do is not define it here, not declare it here, whoops, but declare it out here. Okay, that trades us for a second problem, which is frames per second might not have been initialized. So we could give it a default value either up here or down here. We could say that wasn't an integer using 60 frames per second, like that. There's lots of things you can do when you catch an exception. One is to do something like this, assign a default value. So you see that's fixed it. Now no matter which path we take through the try-catch block, if this is successful, we'll assign what the user typed. If it's not successful, we're going to jump into the catch block and assign 60. So let's just show how it's working here. This is one simple way to deal with an exception. I enter something bad. It says that wasn't an integer using 60 frames per second. So I set it to 60. Pass that to pause, which pauses for 16 milliseconds. That's 1,000 divided by 60. Okay. Another thing we could do here is we could put this whole thing in a while loop with maybe a flag or a break statement right here getting us out of it. So for example, we could go, if we put a break here, then we go while true, like that. Now we can say, instead of doing that, we can say try again. Okay. And so the way that this code works is we're in a while loop. The break statement will get us out of the while loop. So that's what break does. It breaks you out of the innermost loop or switch statement. Not if statements though, or try or anything like that. So if this is successful, the next line that we execute will be break. So we'll break out of the loop and come here. If this is not successful, it's going to jump immediately from here into here. It won't execute this. And it'll say that wasn't an integer, try again. Okay, so that's another thing that we can do. Now this does cause us another problem, which is that, I'll show it to you here. We get that. We go into well, it looks like an infinite loop. What's happened is I typed something that wasn't an integer, and it went into the buffer inside the scanner. The scanner tried to convert it to an integer. It failed, so it triggered an exception, which brought me to here. But then it never removed the thing that I typed from the buffer. So the next time I go back, it tries to do the same conversion again on the same item. So I forget what I typed. It was like FD or something. But FD is still there, so it's never coming back to the user. It's just going round and round and round. So when you're doing this with the scanner, you have to do something like this. sc.next will accept the next token on the scanner as a string. So that clears off the scanner's buffer. So if I rerun this now with this in here, so this, again, if an exception is thrown, we jump straight to here. We tell them it wasn't an integer, and then we remove whatever they typed from the buffer with this statement here. There we go. That wasn't an integer. Try again. How about now? it'll say that wasn't an integer 3 times, because first it tries to convert how, and then about, and then now. And then finally, if I type 50, it will allow it. It will go to the break statement. It will break out and go to here. Okay, let's see. Yeah, so that's a basic little pattern that you can use when you're getting input from a user like this. You'll have to do something different if it's in a graphical user interface. The other place that we might get an exception here, by the way, is up here. This is a division statement. It's integer division. If I try to divide by 0, so if you say how many frames per second and the user enters 0, we get this exception. And you can see, here's the stack trace. It's saying it came from this line where you called pause. So you called the pause method, and then up in the pause method you tried to do this, and that caused an arithmetic exception. And notice the little message here, division by 0. So this caused a different kind of exception. So it threw the exception from here. It's an unchecked exception again, so it doesn't have to specify it's throwing it. But it threw it from here, came back to here, and we said, okay, go check the catch blocks. This one does not match. It's not an arithmetic exception that we're catching here. It's an input mismatch exception. And there are no more catch blocks, so this is an unhandled exception, so it throws it and halts the program. So what we want to do is, you can have as many of these catch blocks as you like for all different types of exceptions that might be thrown by your code. So, oops. We can say system out println bad value. And here's something kind of cool. The E is a variable of type arithmetic exception that's accepting this object arithmetic exception. And this object has methods that we can call, and a good one is getMessage. So I'll say bad value getMessage. We don't have to do this time because we accepted it. We know that what we got was probably a 0 or a bad number, and then it was a valid integer. If we get past this one, it was a valid integer, so we don't have anything to remove from the buffer. So how many frames per second? If I say this, it says that wasn't an integer. Try again. If I say 0, that's going to trigger the arithmetic exception. What went wrong there? Oh, whoopsie! I made a mistake. I don't know if any of you caught it, but I put it in the wrong place. Darn. So it's not this line. I'm just getting the input. I'm not actually using it. It's down here when I call pause. That's when I might get that error. So I want to put the catch there. So unless I put this inside the loop, we're not going to be able to loop back. So the tight little loop up there is only going to now handle things that aren't integers. If I enter 0, it's going to allow it. It's going to come through to here, and this one is going to throw the arithmetic exception. So it'll skip over this catch block and go to this catch block instead. There we go. Bad value. And see the division by 0, that comes from e.getMessage. Not all exception objects have messages. I believe this one does not. So if I trigger an input mismatch exception, I can try and print the message there, but I think it's either null or an empty string. Let's have a look. So bad integer. Yeah, it just prints null. So this one doesn't have a message, it just returns null. But the other one, the 0, division by 0, does have an error. There's one other error that we can throw up here, maybe. I'm not sure, actually. If I enter a negative frames per second, I'm actually not sure what that will do. So let's find out. How many frames per second? Say -6. There we go, illegal argument exception. So yet another type of exception that we can throw there. So we could catch that one too. Catch. So what's happened here, just to be clear, is here I called the pause method. Up here it tried to sleep, but because, there you go, timeout value is negative. Because I divided by a negative number, that made this a negative amount of time to pause, and it doesn't like that. So I can finally catch my final exception here, system out println bad value, and I can do this again, e.getMessage, to print out that message timeout value is negative. So these ones here are just catching the error. It's just a little bit more graceful. You can give the user a better message. So negative 43, there we go. Bad value, timeout value is negative. How many frames per second? 34. There we go. Just checking the success case to make sure it still works. So we've covered a lot of ground here. We've learned that exceptions are objects that get thrown by another piece of code, and you can catch them. There are some exceptions, like interrupted exception, which are called checked exceptions. You have to either say you're going to throw them by adding a throws line up here, like this one does, or you have to catch them. Otherwise, it's a syntax error. But most exceptions are not like that. Most exceptions are like input mismatch exception, illegal argument exception, and arithmetic exception. These ones, even though the code can throw them, you don't have to say what you're going to do with them. So by default, they'll get thrown and halt the code, but you can choose to catch them somewhere, and we're catching this one here, and then you can behave more gracefully. So up here we saw a nice example of removing the offending thing from the queue and then looping back. If we put this inside the loop, so this is our while loop right here. Yeah. I think we're going to have to, yeah, this might not have been initialized. So we're going to have to, oh no, sorry, I put this in the wrong place. So what we want to do here is we take this and we put it here. So, so this is getting complicated now. But if you wanted to do this in the loop, you would do something like this. So if this is successful, we'll continue to do this try catch block. And if this is successful, we can break out of the loop. Otherwise, we catch an exception and give a message, or we catch an exception from this try block down here and give a message. Now let's see if this works. So this will continue to loop until we successfully call pause. So how many frames per second? FDS. So this line throws the exception. I catch it down here and it says that wasn't an integer. I remove the token. Here's another error, 0, bad value. So we got past here, frames per second is 0. We go here, it calls frames per second with 0, which throws an which throws a bad value. Yeah, division by 0, which happens right here. So it catches that exception here, and then it loops back up. This block here did not throw an exception, so this one doesn't go. And then the other one we can do is -6. Bad value, timeout value is negative. That got caught here, the illegal argument exception. And finally, if we enter something correct, then it will do the pause. So this didn't throw an exception. This didn't throw an exception. So it breaks, and which breaks us out of the loop. Okay, so we covered a lot of ground there. That was a kind of a complicated example. I'm going to put it back the way that it was before, like this. So that now, here we go. Oh, we have to do a break here. There we go. Now it can recognize it. Okay, so now we're only looping. We're back to just looping on the bad input, and then in here it'll just give me the correct exception. Okay, so so we've looked at controlling user input with loops. We've looked at catching an exception in a simple way right here. You can get the message of the exception object, and we've looked at catching multiple different kinds of exceptions here. Let's just take a quick look back at the guide. So this goes through a bunch of examples. I would read over them if I were you, and it refers to exception 1. It shows you how to do multiple catch blocks right here. There is an exception 2 program as well that shows you that, so you can take a look at that on your own time. And this is the class hierarchy. So everything is an object. Exceptions are a subclass of something called a throwable, and the highest level exception class is just called exception. Then there are runtime exceptions, like illegal argument and input mismatch, and arithmetic exception, and also number format exception. So none of these are the ones that are unchecked. You don't have to specify what you're going to do. But things that subclass directly off of exception, like file not found, which we won't look at in this course, or interrupted exception, these are the checked ones that you have to look at. You can also, by the way, you can take advantage of polymorphism. Since every kind of exception is just an exception object, you can actually do things this way as well. You can say, you could replace all of this with catch exception E, and just say something went wrong, and then maybe just do get message. So this will catch any exception that'll happen, because they're all subclasses. All the classes of exception are subclasses. So if I enter -5, it'll say something went wrong, timeout value is negative. So that's the one where it threw the illegal argument exception. And here's the one where it throws the arithmetic exception. You get a different message there. So that's another way that you can do it. Wait. Let me copy this and put everything back the way that it was. And we'll add this in, and I'll just comment it out as an example for those of you that want to go get this code later. Okay, so do read over the guide. And there's a little note here on how you have to use sc.next to remove the token from the buffer if it's an input mismatch exception caused by something like sc.nextInt. We talk about checked and unchecked exceptions here, and so on. So there's a few pages of stuff here to go over on how exceptions work. Now, I would like you guys to try an exercise. I want you to do the read-only string array. So I've given you some code for this called read-only string array, and I'm going to show you how to use it. I want you to create a test string array class with a main method. Basically, the read-only string array is an object that contains a string array. You can specify the string array, the array of strings, when you create it. And then it's got a get method. So what you can do then is you can say .get, give it an index, and it will retrieve the string at that index. And of course that can cause an array index out of bounds exception. So that's something to catch. So there's two different types of exceptions that can cause your main method to crash. Put exception handling into your main method. So let me just walk you through the first couple of bits of it. So I'm going to create new Java class test string array, like that. And read-only string array is right here. So I'm going to go PSVM for a main method. I'm just going to go read-only string array, ROSA, read-only string array, also the name of my daughter, equals new read-only string array, and I'm going to give it, there's a couple ways to do this actually, it's kind of cool. You could say, okay, I'm going to go do a new string array with, Sam, Rosa, like that. So that creates a new one with a read-only string array, a new set of strings, and then I can say system out println Rosa get 0 will get the first item in that string array, and system out println Rosa get 1 will get the second item, and then this will throw an exception, get 2. So if I run this, the read-only string array code, by the way, is right here. Oops, I ran the wrong thing. Shift F10. There you go. It printed Sam and then Rosa, item 0 and item 1, and then it printed index. It threw an exception. So your job is, there's a couple of exceptions this can throw. Your job is to catch both, figure out what they are and catch them. The one thing I wanted to show you is, because of the way this constructor is defined, I can also do this, which is really kind of cool. I can just specify a bunch of strings. Bob, Ahmed, I don't know, Rohan. There we go. So I can put as many, instead of going to the trouble of actually putting an array here, I can actually just put a list of strings here, and I can make it as long as I want, and it's going to auto-convert them to an array and pass that to the read-only string array. And the reason why it does that is because of this cool little thing. If you look in the read-only string array, what you might have been expecting to see is a constructor that looks like this. If I had done that, because that's the usual way to do it, then this would be an error. But there's another way to specify that you want an array, which is to use ... You can only do this for the final parameter in a list of parameters, but this says accept any number of string parameters and put them into an array and assign that array to contents. This is called the ellipsis operator. If you want to look that up, it's in Java called the ellipsis operator. You might be able to Google 3 dots and find it as well. So that's kind of cool. Just a little optional thing that I threw in there because I thought you might like it. It explains how a method like printf can work. Those of you that have been using system out printf, you know that it can take, it seems to be variable, the number of parameters it can take. It has to take one string, and then it can take any number of other things. And it does that basically like this, object, ... So it can take any type of object that you put there. Okay, that's it. So your job is to just put exception handling into test string array. Figure out where it goes. So I've shown you one exception it can throw, but there's another one that it can throw as well. So hint, think about the 0 case. What does it mean to have a 0 array? And see what exception that will throw. Okay, so give that a try. In the next video, we're going to look at throwing exceptions. So we've seen catching them, but now we're going to do the other side of it, which is we're going to show how to throw exceptions. It's pretty easy and it's really useful. Okay, so I'll see you in the next video.